Well, welcome back. We've got an exciting topic tonight. We're going to get back into a lot of algebra. And our topic tonight is called relative extrema. Now, that at the end might be throwing you off. That is just plural for extremes. So what's that is referring to is relative maxes and relative mins. Okay, so don't let that word extrema throw you off. That just means both a relative max and a relative min. So one of our main goals tonight is to distinguish between relative and absolute extrema. And again, remember, extrema is plural for maxes and mins. So a relative max or min, or relative extrema, is what you've been talking about your entire math career. It's the obvious one. Let's go to B and circle it. So yeah, I would get that sketched in your notebook, of course. B, we would consider a relative max. Okay? You would look at it, you would say it increased, it decreased. This is the highest point there. It's higher than the thing to the left and to the right. As you continue, I hope you would say D is a relative min. Okay, it's smaller than the thing to the left and to the right. As I continue, hopefully you would say E is a relative max. Again, normal max, and hopefully you're thinking to yourself F is a relative min. Okay, so now the question is, how about this word absolute? So what I want you to write down in your notebook there, absolute is a must. Okay, and there can only be one. So only be one for the absolute. Whereas relative, you could have several. Okay, so if I say it's a must, okay, it is the absolute, it is the one and only. Okay, maybe make a note, the one and only highest or lowest point. So let's start with the absolute min. Is there one and only point that is the absolute lowest? Hopefully you would say that's A. There is nobody lower than that point. Now your absolute max I tried to get a little sneaky on. Your gut might want to say G, but hold that thought. What is at G? What type of circle? It's open, which means there's nothing there. So your absolute max, the next highest point would be B. So I would say that is my absolute max, which also happens to be a relative max, no big deal. But you can only have one of the absolutes. All right, so let's go ahead and get this sketched in our notebook. We have function f of x, and the question is this first function, or what intervals is this function increasing, and when is it decreasing? So the one note I want to make here is that you are always reading, just like you do in English, from left to right. Okay, it's not an option. We're going to start on the left, and we're going to work our way to the right. So you can follow my little cursor here. As I start on the left and I follow the graph, if you were to walk on this graph, would you be walking up or down? And I think it's extremely obvious. Hopefully I'm not insulting anyone, but I think you would say you are definitely walking up, hence you are increasing. And you walk up until you get to the highest point where you're no longer walking up, and then you start to walk down, which would be you are decreasing. So we want to be able to state the intervals that we're increasing and decreasing. So I would say we started way over here, which we would call negative infinity. Remember, we're describing the x values. And I'm increasing until I get to here, and again, the x value is 1. Now, the age-old question is, would I put a parenthesis or a bracket around that? Am I including 1 or not including 1? Well, think about this. As you're walking up and you get to 1, are you at the highest point or are you still increasing? I would say you're at your highest point. You're no longer increasing, so I'm going to slap a parenthesis around there. Okay, I'm not including 1 because I'm not actually increasing at 1 anymore. I'm there. And then once I got to 1 and I continue on, I remain to decrease. So I would say I'm decreasing from 1 to positive infinity. Now the question is, big question here because it's obviously calculus, what do we know about f prime? And again, that prime means talk about the slope. Okay, calculus comes down to slope. If you ever get stuck, just talk about the slope of something. So what I want you to do is in your picture, I want you to draw a couple little tangent lines in here. Okay, so not that you need a number on them, but what do you know about the value of these tangent lines? Are they positive or negative? Do they have positive slopes or negative slopes? They're definitely positive until I get to the top here. And when I get to the top and I draw that tangent line, draw that in your notebook there, here's what we want to say. At x equals 1, f prime of x equals, notice it's flat. The slope of a flat line we should know by now is 0. And that's kind of one of our big draws today. We want to know that x equals 1, the slope is 0. And then just to be clear, if I put tangent lines on the rest of this graph, this we can see has a slope that is negative. So let's go ahead and say f prime is greater than 0 and f prime is less than 0. All right, let's take a look at the second picture here. And again, get it sketched in your notebook. We want to talk about increasing and decreasing. And again, go back to the idea you have to start left to right. So I start on the left side of this graph. If you were to walk on it, would you be walking up or down? Well, of course, you're walking down, so that would be decreasing. So I'm going to say from negative infinity, and I'm going to walk down until I get to this point, which is at x equals 0. So I'm going to start with my decreasing, from negative infinity until 0. Again, once I hit 0, I am no longer decreasing, so I'm not going to include 0. And then as I continue walking, I'm increasing from 0 to infinity. Oops. Okay, now again, the big question is, what is f prime? All about slope. So I want you to think of your tangent lines. If I put tangent lines on here, okay, again, I'm looking at the slope. If you were to ski down it, the slope is negative, so I'm going to make a note, f prime of x is less than 0. And then if I were to walk on this side, f prime is greater than 0. But what happens right here at x equals 0? Okay, if I were to put a tangent line there, it's not flat like it is in this previous picture. It can like teeter-totter, and we've talked about this before. I want to say at x equals 0, f prime does not exist. And we called this a cusp because it's not a corner, it's not a right angle. We call it a cusp. So the next definition you have to be aware of is the term critical points. And let's star this in your notebook, maybe put a big box around this. Pretty much for the next couple of weeks, all we're going to be doing is finding these critical points. So our definition that we should have down word for word is critical points are the x values where the derivative of the function is 0 or undefined. Since all these places are relative or local, extrema could occur. And that's what we just showed you in the past 6 examples. Anytime we had a slope of 0 or didn't exist, that is referred to as a critical point. And again, we use the x values. So question 1, find all the critical points. Alright, so all we did is we said we have a critical point when our slope, so when f prime of x equals 0 or f prime of x does not exist. Okay, and that's got to go through your head every single time, and let's write it down underneath the problem. I have a critical point when the slope is 0 or does not exist. Now, typically the only time I'm going to get a doesn't exist is if I have a fraction. Okay, obviously if the denominator equals 0, you have this undefined or does not exist slope. And then sometimes in my trig problems, I might get, undefined parts such as tangent or secant or cosecant. So my first goal is to set the derivative equal to 0. So I'm going to find f prime of x. So we get a nice 2x plus 8. Okay, and it says set that equal to 0. So 2x plus 8 equals 0. Okay, notice 2 easy steps. Take the derivative, set it equal to 0. Solve for x. Subtract the 8, divide by 2, x equals negative 4. Okay, so I just want you to highlight this and say we have found our first critical point. Notice I didn't have to worry about the doesn't exist section because I didn't really have a fraction or a trig function. Alright, next example. Let's find all the critical points. Let me just slap an f of x equals here. So find that critical point, setting this derivative equal to 0. Let's see, so I get 6x squared plus 6x minus 12 equals 0. And you can write it all in one line like that. F prime of x equals this chunk equals 0. And I'm going to pull out a 6 there, so I'm going to say that's x squared plus x minus 2 equals 0. Make sure you're carrying that equals 0 down. Now don't lose your 6, of course, that stays out in front. X plus 2, x minus 1. If I tee that up, watch all 3 pieces. Does 6 equal 0? Does that make any sense? Of course not. Here I get x plus 2 equals 0, so x equals negative 2. And x minus 1 equals 0, so x equals 1. So I actually have 2 critical points in this example. This, of course, got rejected. Now we're going to get into what we call the first derivative test. So here are the rules. Again, these should all be in your notebook. Let's get them in nice and neat. Pause it if you need to. Step 1, find all the critical points. Well, that's pretty straightforward. That's what we just did. That's when f prime of x equals 0, or, don't miss the second part, f prime of x does not exist. Make sure there's two things there. Then we're going to create what we call a sign chart that is labeled. All right, so if you've taken your pre-calc before, this is the way we're going to do it this year for the AP. 3, test all values in f prime of x. And 4, state your solution. Now, I'm going to have you copy down one more thing about our first derivative test before we actually dive into an example. So again, if you need to pause it, go for it. To find, and again, here's how you find this use this first derivative test. To find increasing and decreasing intervals, test the intervals between the critical points to see if f prime is positive or negative. Intervals in which f prime is positive indicate f of x is increasing. Intervals in which f prime is negative indicate that f of x is decreasing. Now, I think that makes a lot of sense. Picture a parabola. Okay, if this is f of x, what do you know about f prime here? Well, f prime is positive. Okay, the slopes are positive, and that tells me that f is increasing, and that's what this says. If f prime is positive, that means f is increasing. Look at f prime on this side. The slopes are negative. So if f prime is negative, that should tell me that my function f of x is decreasing. And then finding relative or local maxes and relative local mins. If the derivative of the function changes from positive to negative at a critical point, there is what we'll call a relative max at that number, assuming the function is continuous there. If the derivative changes from negative to positive, we'll say there is a relative min at that critical point. All right, now that that's copied in your notebook, we're ready to dive into some examples. State all relative extrema and find the intervals where f of x is increasing and decreasing. So again, this word extrema is plural. It wants you to state both maxes and mins. And of course, that's relative maxes and mins. All right, so if you look back at those steps, you just copied down the first step, said find all critical points. So I'm going to take the derivative and set it equal to 0. 2x minus 6 equals 0. Add the 6, divide by 2, x equals 3. All right, step 1 is done. Step 2. It says we're going to create a sign chart and labeled correctly. This is not an option for our AP. So here's what we do. Here's what a sign chart is. It's basically like a number line. The top always gets labeled with f prime. The bottom gets labeled with f. Okay, and that's why I said we're not skipping this labeling step. It is not an option on our exam. Your critical points go on the number line. Well, we only had one, so I'm just going to stick x equals 3 on there. Okay, now, all you do is you test a number. So if you look at our step 3 says test a number in f prime. Okay, so I'm basically going to plug any number to the left of 3 in f prime and anybody to the right of 3 in f prime. And you don't have to write them down, I will for you. I'm going to test 0 on this side, that's to the left of 3, and I'm going to test 4 on this side. And I want to be clear, I am plugging them into f prime. So, the other thing I want to state is I don't actually care what I get, number-wise. I care whether it's a positive or a negative. So here's my f prime function, and I'm just plugging in 0. I have 2 times 0 minus 6. Don't even tell me what the answer is, just tell me whether it's positive or negative. 2 times 0 is 0, minus 6 is a negative number. You put a negative sign there, one negative sign, one big one, and you always show then that this function is decreasing. So a nice line with an arrow on the end. Now we'll plug in 4. Again, don't tell me what the number is, I want to know if it's positive or negative. 2 times 4 minus 6. 8 minus 6 is a positive number. You put a plus sign there, nice big one, and you put an arrow on the end, like this, showing that your function is increasing. Now this describes your function to a T. Look at this sign chart that we made. Okay, the top row talks about f prime, and the bottom row describes what f is now doing. So here's what I can say. F is increasing. Whoops, f is increasing. And here's what you're writing down. It's not an option. This is what the AP exam will be looking for. We have to justify everything we do. On the interval, so if I look at my arrows, this is decreasing, this is increasing. So 3 to infinity. Now I have to say why. Why do I know that it's increasing? Well, now you look above and you say, because this is positive and that's f prime. Because f prime of x is positive. Now the easy way we're going to say that, of course, is to say that it's greater than 0. And this is 2 points on your AP exam. Let's make sure it's labeled perfectly. F is increasing from 3 to infinity. F prime of x is greater than 0. Let's do one for decreasing. F is decreasing on the interval negative infinity to 3. How do I know that? I look at this sign chart. I have my arrow going down for decreasing, talking about F, negative infinity to 3. And how do I know that it's decreasing? Now you look above. F prime, we're talking about calculus now, is negative. So I would say F prime of x is less than 0. Now, I've talked about increasing and decreasing. I need to state any relative extrema. So the question is, do I have a relative max, min, or both? Well, look at your arrows. Like, this should be a no-brainer. Follow the arrows. It went down, now it went up. Look at my arrows. Did you make a max or did you make a min? Clearly, I have a min. So F has a min, a relative min. And you can abbreviate rel min, that's fine, that's full credit on their exam, at x equals 3. Okay, so that's 1 point for that. Now I have to justify. How do I know I have a min? Well, remember it's calculus, so say something about the derivative. F prime changed from negative to positive. And again, that's what they're looking for. Okay, don't try to make up your own lingo here. It should all be the same thing. F has a relative min at x equals 3. F prime changed from negative to positive. And it's that simple. So we'll try a few more together. All right, next example. F of x equals x to the 4th minus 8x squared. All right, you should be able to pause this, and your first job is to go get any critical points. So pause it, see what you get. All right, what do you think of my critical points? I'm hoping you have the same thing. Simple derivative of 4x cubed minus 16x equals 0. Make sure it says equals 0. That'll be worth a point. They're looking for that setup. I pulled out a GCF of 4x. Okay, then I'm left with x squared minus 4. I factored that one more time to x plus 2 and x minus 2. So I have 3 critical points when I set each piece equal to 0. On this side, of course, I get x equals 0, 0 divided by 4, x equals negative 2, and x equals positive 2. All right, so on my sign chart now, I need 3, and they go in order. Negative 2, 0, and 2. Not an option to label this. F prime goes on top, F goes on the bottom. Okay, now, you're just picking numbers and plugging them in. So the more critical points, the more numbers you have to test. I'm going to test a negative 3 here, a negative 1, a positive 1, and a 3 here. Now again, some people make this a lot harder than it needs to be. Box your derivative in. Okay, your factored form. Find the easiest version. And I think factored form is the easiest. Box that in. I don't care what number you get. I care whether it's positive or negative. So watch how I do this. I'm going to start with my 3. Okay? I'm going to plug this 3 into 4x. Don't tell me the number, just tell me if it's positive or negative. 4 times 3, I'm going to put a plus sign right above here. Now I'm going to plug 3 in here. 3 squared minus 4. 9 minus 4 is a positive. And what is a positive times a positive? Positive. Okay, don't worry about actually multiplying the numbers for the most part. Just figure out what sign you're going to get. Let's plug a 1 in. Okay, I'm going to plug a 1 into 4x and I get a positive. I'm going to plug a 1 into this term. 1 squared is 1 minus 4 is a negative. A positive times a negative is a negative. Plug a negative 1 in. 4 times negative 1 is a negative. Negative 1 squared is 1 minus 4 is a negative, and a negative times a negative is a positive. Plug a negative 3 in. I get 4 times negative 3 is a negative. 3 squared is 9 minus 4 is a positive. A negative times a positive is a negative. Okay, now finish your sign chart. Describe f. If f prime is negative, f is decreasing. If f prime is positive, f is increasing. If f prime is negative, decreasing, and then again, increasing. Okay, this sign chart needs to be perfectly labeled. It is not an option. F prime and f, correct signs, correct arrows. Now, I want this to be clear to everybody. It's not Algebra 2. These will not alternate on 90% of the problems, okay? So don't think if you know this is negative, it's going to go negative, positive, negative, positive. It is not Algebra 2. Okay, these are going to change quite a bit. We just got lucky there. So let's describe what we have. Let's talk about the intervals where f is increasing. I would say f is increasing, and now you just describe where your arrow went up. From -2 to 0, and from 2 to infinity. And how do I know that? Now justify. Justify with calculus. Describe f prime. F prime is greater than 0. Okay, it's positive. Describe where f is decreasing. Look at your down arrows. -infinity to -2, and 0 to 2. How do you know it? Well, describe with calculus. F prime is less than 0. All right, let's talk relative maxes and mins. How many do we have? Let's just follow the arrows you drew. It's that simple. Relative max. Okay, I went down, then up. That's a min. Now I'm up, then down. That's a max. Down, then up is a min. If you follow the arrows, you really can't screw it up. If you even draw in what's happening. There you go. We have a relative max at x equals 0. Justify. How do you know it's a max? Use calculus. F prime changed from positive to negative. That's what we're looking for. I have relative mins at x equals -2 and x equals +2. How do I know? Use calculus. F prime changed from negative to positive. And again, that's simple. All right, let's throw another one up there. Get all critical points, make a sign chart. Let's see how fast we can go. Take your derivative, set it equal to 0, get your critical points, see if they match with mine. So hopefully you've paused it and you've checked mine. I brought my 3 down, kept my, whoops, didn't mean to do that. Brought my 3 down, kept my inside, raised it to the second. Derivative of the inside is 2. 3 times 2 gets me 6 times that quantity squared. So we should be pretty good at the derivative part by now. Tee it up. On this side I get 6 equals 0, which means nothing to me, that's garbage. On this side, I set that quantity equal to 0. To get rid of the square, I simply just square rooted both sides. Square root of 0 is 0, and solve for x. So I actually only have one critical point to test. Okay, so I'm testing 3/2, label f prime and f. And you just need to pick somebody bigger and smaller. So I love 0 if I can use it. And again, say to yourself, 2 goes into 3 how many times? 1 and a little more. So 2 is a safe number to pick on this side. Now I can't stress enough, I don't care what the number is. I care whether it's positive or negative. So I'm going to pick the most factored version I have, kind of box that in. And that's where I'm plugging this in. Alright, is there any place to plug the 2 in on this side? No. So I basically get 6, I get a positive times whatever this turns out to be. Well, think about this. No matter what number you plug in, you're doing what to it? You're squaring it. And anytime you square something, you're going to get a positive. So it doesn't matter what I plug in, I better get a positive number. It's not possible to get a negative number. When I square something, I get positive times a positive 6 is always positive. So that tells me I've got a positive when I plug in 0, a positive when I plug in 2. This function is never what? It is never decreasing. Now watch how this gets written up. Oops. F is increasing. You can't say everywhere. I want you to think about that. You can't say everywhere. The reason this is a critical point is because the derivative equaled 0. Okay? If you have a 0 slope, that means you stopped increasing. So I'm going to say I'm increasing from -infinity to 3/2, and then again from 3/2 to positive infinity. At 3/2, I am not increasing. I want to be very clear. I am not increasing or decreasing here. Okay? F is, oh, and I need to justify. F prime is greater than 0. Okay? F prime of x is greater than 0. Is f decreasing? Obviously never. How about any relative extrema? Do I have any maxes and mins? Well, no. I can't have a max if I go up and I go up more. Okay, I certainly can't have a min. I didn't go down and up. I didn't go up and down. All my function is doing is going up. So what I want to do is try to sketch out what's happening here so you could visually see it. Basically, okay, when I get to 3/2, 1.5 there, I have this function that's increasing, and it has a 0 slope, and then it increases some more. So this function, and that's what this is telling us, this sign chart is telling us, is that this function is always increasing, but at 3/2, It's a critical point, so it has a 0 slope. So right here I should have a horizontal tangent line. It's pretty neat. Alright, now they're going to start to get a little uglier. So let's get our critical points. Set that derivative equal to 0. So let's go 4/3 x minus 3/3 is to the 1/3 minus 4/3 x, if I subtract 3/3, to the negative 2/3. Now I have to set that, of course, equal to 0. Okay? Now it's all that your favorite factoring. You got to pull out that GCF. Alright, so I can take out, I'm looking at this side of the minus sign and this side of the minus sign. I can take out the 4/3 x, to remember, to the smaller exponent, to the negative 2/3. Okay, so when I write what's left, basically I need somebody left on this side of the minus sign, somebody on this side. So if I take out the 4/3 x to the negative 2/3, imagine subtracting negative 2/3, you're left with 1. So I get x to the first. Minus, if I took that out completely, I should get x minus 1. Okay, that's what I'm setting equal to 0. Now it might look ugly, but go with me here. Basically, I have my 4/3. This x to the 2/3 moves to the bottom. And I have the quantity x minus 1 on top. Alright, and again, that's what I'm setting equal to 0. Now remember, a critical point is when you set your equation equal to 0. But you also have to consider when the fraction does not exist. So when I have this fraction, I have to set both the numerator and denominator. Okay, so let me explain why again. I set the fraction equal to 0, that's really when the top equals 0, but a critical point is when that equals 0 and does not exist, and that's when the bottom equals 0. So basically I'm going to take the top, 4 times x minus 1, set that equal to 0, and I'm going to set my bottom equal to 0. Okay, so if I factor that, I basically get x equals 1. If I pull this apart, that means nothing, and I get x equals 0. So I should have 2 critical points, one at 0 and one at 1. Make sure this gets labeled f prime and f. And remember, I'm plugging these into f prime, and I don't care what the number is, I just care whether it's positive or negative. So I'm going to start with a 2. Here is my f prime function. Okay, on top, 2 minus 1 times 4 is a positive, divided by 2 to the 2/3 is a positive times 3 is a positive, positive divided by a positive is a positive. Now I've got to plug in a half. Okay, well anybody between 0 and 1, I'm going to use a half. 1/2 minus 1 is negative times 4 is a negative, divided by 1/2 to the 2/3 is a positive times 2, and a negative divided by a positive is that negative. And now I'm going to use a negative 1. Negative 1 minus 1 is a negative times 4 is a negative, divided by the cubed root of negative 1 squared is a positive. So I get a negative divided by a positive is a negative. So what does that tell me this function is doing? Well, it's decreasing, decreasing some more, and then increasing. Alright, so let's rate our statements. I know f is increasing from 2 to infinity because f prime is greater than 0. Okay, so again, I'm looking at my arrow going up, describing it with calculus, the f prime line. I know f is decreasing. Now notice, again, you have to write it in 2 separate steps. You cannot say from infinity to 1, or negative infinity to 1. It is not decreasing at x equals 0. I am decreasing from negative infinity until 0, and then from 0 until 1, because f prime is less than 0. Now let me show you another little thing you can add to your sign chart here. Remember, the derivative equaled 0 at 1, so you could put a 0 above there, and then remind yourself that at 0, the derivative actually did not exist. Okay? So again, at 1, that's when my slope equaled 0, and at 0 was when my denominator equaled 0 or it did not exist. And then lastly, I have a relative min only. Follow your arrows down, down, then up, makes a min. At x equals 1, f prime changed from negative to positive. Well, we're going to get a lot of practice over the next couple days with finding our critical points, and that leads into some heavier calculus that we'll get to later on. Have a great night. We'll see you tomorrow.